Hello, everyone. Thank you so much for tuning in. My name is Manoj Gunti. I'm the Product Marketing Manager for Google Cloud's Apigee API Management Platform. And today, I'm joined by Mudit Purwar from T-Mobile. Hi, Mudit.
Thank you, Manoj. Hello, everyone. My name is Mudit Purwar, and I'm a principal engineer in API Center for Enablement, leading the API DevOps engineering team, along with driving the CI/CD and self-service automation tools initiatives for API program at T-Mobile.
Welcome, Mudit. So in this session, we want to explain and show you a live demo of how you can extend Google's industry-leading AI and ML technologies to your API programs. For many years, we had the opportunity to work with customers across the globe and across industries. Throughout this journey, we have observed that the role of APIs and API management has been continuously evolving. What used to be just an agent for accessing various systems is now actually an agent for driving digital transformation programs. While APIs continue to be built and consumed by developers, IT leadership, marketing, and other line of business owners have started looking at APIs as something beyond just a piece of technology to drive real digital transformation programs. And when you align APIs with your digital experiences, it also creates an upstream impact on the value chain. When your core business critical applications are powered by APIs, imagine what impact downtimes, performance degradations, or even security incidents can have on your customers and partners. Therefore, API operations becomes extremely critical to ensure a connected and seamless digital experience is delivered to all the stakeholders. However, operations teams are under immense pressure. As a sysadmin, how do I ensure my APIs are up and running and performing as expected? When there is an issue, how do I quickly identify the root cause? And I want to do all of this without getting distracted by false alert noise. As a SecOps person, I want to ensure my APIs adhere to compliance requirements. I want to protect my sensitive data from abuse and quickly diagnose security incidents. And the good news is, as you build and scale your API programs, there's a gold mine of API data that's collected across the entire API value chain, all the way from your backend targets to the front-end apps. And this data can be leveraged to solve these problems. Google Cloud's Apigee API Management Platform applies industry-leading AI and ML models to harness the power of your data. With features like API monitoring, anomaly detection, security reporting, and bot protection, you can now ensure that your APIs are always available, secure, and performing as expected. With that, let me turn it over to Mudit to talk about T-Mobile's API journey and how they have put AI and ML powered capabilities into practice. Over to you, Mudit.
Thank you, Manoj. We at T-Mobile are on a journey to change the wireless experience of our customers. In today's digital age of mobile web, artificial intelligence, machine learning, Internet of Things, changing the customer experience is impossible without leveraging the power of APIs across the digital value chain. Hence, let's reflect back on our API journey so far. We started with Apigee API Gateway back in 2015 with 2 dedicated API teams developing APIs to expose legacy services for a new radically simplified frontline application. In 2017, to bring some cohesiveness among the growing API teams, ProxyGen, a homegrown API development tool, was launched. It would take the API contract or the Swagger as an input and generate the Apigee API proxy bundle, check the code into the source code management repository, launch the CI/CD pipelines, and deploy the Apigee API proxy into Apigee Edge. It was an instant hit with the API developer community at T-Mobile. API Center for Enablement was launched in 2018 to address the growing challenges with the API program that was gradually emerging. Same year, we launched a suite of API-first development tools to enable the domain teams to self-serve themselves for any need on the Apigee API platform. And here we are in 2020 with 80 plus business domain teams developing APIs within T-Mobile. Together, they have produced 1,300 plus API proxies, resulting in over 9 billion transactions per month. Let's look at some of the API operational challenges that come with this kind of growth. Here are some of the challenges we continually face every day in the API operations space. And some of these might resonate with your company's API operations as well. Securing and protecting APIs from external and internal bad actors, bot traffic, denial of service attacks, broken authentication, and so on and so forth, and trying to continually maintain a secure posture to have a seamless digital experience for our customers. Observability into unexpected and unforeseen API runtime issues and contextual information about those issues is a key challenge to improve the API availability and performance. API platform scalability to handle the sudden traffic burst during our Uncarrier Move announcements, like our latest Uncarrier Move, Scam Shield, and promotional events like Black Friday, holiday season, etc. On a similar note, capacity planning to support new innovative growth that we foresee beyond wireless, like our banking service, T-Mobile Money, our TV service, T-Vision, and others. And then streamlining the API consumer and partner onboarding process to access T-Mobile APIs to improve the API consumer and partner experience and agility. AI and ML have definitely helped us in addressing some of these challenges. AI and ML features like API monitoring and Apigee Sense have definitely empowered our everyday API operations. By covering our blind side for unforeseen API traffic and performance issues, which could go undetected and cause severe API availability incidents and impact the business negatively. Anomaly detection in API operations by applying AI and ML models is aligned with T-Mobile's observability objectives, like proactively monitoring the systems and APIs, detecting issues prior to any negative impact on the business, and developing auto-healing capabilities where possible. Alerting and notification combined with anomaly detection for real-time traffic and performance issues has improved our team's productivity and significantly reduced the MTTD mean time to diagnose API incidents. With the added suggested operator controls in the form of predetermined resolution playbooks for any issues, has notably reduced the MTTR, mean time to resolution, of any API incident. Let's look at a demo on how AI and ML have empowered our API operations at T-Mobile.
Let's check out some of the Apigee's built-in AI and ML features in real time and how these features are assisting in keeping T-Mobile APIs available and performant for a seamless digital experience of T-Mobile customers. When you log into Apigee Edge, this is how the landing page looks like. You can get to all the observability related features under the Analyze tab. As a DevOps engineer, I visit the API monitoring overview dashboard quite frequently. This dashboard provides me with a quick summary about the runtime telemetry of all the API proxies deployed in the production environment. For the purposes of this demo, we will be using one of our development environments, wherein hopefully you will not see a lot of broken stuff. As you can see in this dashboard, we get a summary information about a given API environment. Total traffic in transactions per second, overall average error rate percentage, top API proxy response P99 latency value, and total number of recent alerts. It also provides top 3 API proxies with highest value in each metric category. So this dashboard provides a DevOps engineer a pretty good overview of any potential runtime issues with any API proxy. Now let's move on to the Events tab to check if there have been any recent alerts triggered or any new anomalies detected. Looks like we will have to go a little bit back in time to see any alerts and anomaly. Here you go. So the Alert tab shows all the recent triggered alerts based on the predefined conditions set by us. The Anomaly tab shows all the events that deviate from the normal behavioral pattern at the Apigee region, organization, and environment level. These deviations, as well as their severity, is detected by applying the built-in AI and ML models to the historical API data. The cool thing about the anomaly is the contextual information it provides with respect to environment name, API proxy name, target, fault code, region, and the time of the trigger. For a DevOps engineer, this contextual information about an anomaly is really critical and important, as it significantly reduces the overall MTTD, mean time to diagnose, and MTTR, mean time to resolution, for any unexpected and unforeseen issues within our APIs which might be in our blind side. And the amazing thing about this feature is that we do not have to do anything to set all this up. It comes by default and is built in. So based on this contextual information, if a DevOps engineer decides to dive in deeper into the anomaly, he or she can drill down into the anomaly and it will take them into the investigate page or the tab. So let's investigate one of the anomalies. Just looking at the anomaly details on the top, looks like this anomaly was detected due to a reasonably high number of 504 response code in the API flow, which started at around 3:17 in the afternoon. Um, let's look at why the API is returning the 504 error response to the clients. Now, I have various ways and different dimensions that I can find the root cause about this issue. Let's try to determine the fault source in the API flow by looking at different dimensions. I would want to look at the fault source at this point in time. So I'll go select that dimension from the drop down. And as we can see in the API flow, it is pretty obvious that the target endpoint is the problematic area. So let's dig in further by clicking on the target cell. Here we can see the suspected cause determined by the ML model, which can be attributed to the fault code, which clearly states that the error response code is being written by the backend service. Also, there are details for the impacted clients, API clients, and the target endpoints that this API is dependent upon and is at fault for this anomaly. Now, if we want to look at any specific transaction level information, we can do so by going into view logs. This view provides us into specific details about each transaction, like the request URI, which is basically the URI being invoked by the API client, along with the request message ID, what is the status code, response time, fault source, and other details about the client and the transaction. Next, I can do additional things with this anomaly, like creating an alert based off this anomaly. So let's quickly create an alert based off this anomaly. We'll have to hit this button, Create Alert tab, and we'll have to come up with the alert name of our choice, provide the description to it, what type of alert. If we want to base this alert based off this anomaly, we can leave it at anomaly, and then alter the condition if we choose to, or let it remain the same as detected by the anomaly. Then we have to select the alert notification type we want, like email notification or Slack or a PagerDuty notification. Once we have filled out this form, we just have to save this, and we have a pre-configured alert for a given anomaly condition for future proactive notifications. So let me share some sample alert notifications. Here is one email alert notification and how it looks like. It provides us information like the timestamp of the trigger, org name, alert name, summary of the alert, and details regarding the alerts like the condition, trigger value, proxy region, etc. And it also provides embedded links to directly view the event in Apigee Edge. This is how a sample Slack notification looks like. It provides us the name of the alert, organization name, threshold violation details like um, the target latency, proxy name, region, condition information, so on and so forth. It also provides us web links as well to view the anomaly or the alert details directly into the events tab of Apigee Edge. So let's go back. Now I can do further things like I can create a report based off this anomaly to look for any additional dimensions for the further analysis or for an RCA or for management reporting needs. We are really impressed by the API monitoring feature as it has helped mitigate latency and network issues in the past, resulting in increased API availability along with improved performance of our APIs.
Next, let's see how collections can be really useful in making the most out of these AI and ML features.
Collections are a group of API proxies, targets, developer apps based on the organization's choice of dimension. We at T-Mobile have collections based off business domain APIs, which helps us in setting up appropriate alert configurations and threshold values for the same group of APIs. Next, I want to move on to security. Security is one of the single biggest challenge that most of the digital enterprises are trying to solve, and it never gets easier with ever evolving newer threats surfacing every day. In the security reporting overview dashboard, we have information with respect to northbound API traffic for all the given environments, and it tells us, provides further information regarding the API proxies taking active traffic out of the total APIs deployed, total number of shared flows deployed in a given environment, total traffic, and the percentage change in traffic. It also provides the API client traffic composition by region. Since this is one of our development environment and most of our developers are based in US West Coast, hence we can see the corresponding traffic composition being higher in the US West region. Let's move on to the runtime dashboard, which provides us more specific and detailed runtime information about the API proxies. It provides information about the API proxy traffic, percentage change in traffic, and percentage of traffic on non-HTTPS or non-secured port, and the total number of API clients invoking or accessing this API. And if I want to look further details into API proxy, it provides us a visualized graph for the HTTPS and non-HTTPS API access protocols, and then it also provides further data points with respect to developer apps, virtual host, and target endpoints that this API proxy is dependent on. Let's move on to the configuration of the API proxies. Um, this particular dashboard provides us insight into the API proxies security configuration and policy composition, as well as providing information about the virtual host definitions as well. So different categories of policies include the traffic management, security, and extension policies, and all as well as reusable piece of code in the form of shared flows. So virtual host is a definition in API proxy which determines how the API clients uh, or on which protocol the API clients are going to access the APIs. If we want to dig deeper into specific security policy details that are part of API proxy, we can click on API proxy and we can see specific policy names that are part of this given API proxy. And then if there are some security policy standards that have been established by our API program, we can evaluate each and every proxy against those standards to see whether these APIs are in compliance or not. So this dashboard is very helpful in a quick glance on the security posture of our runtime API configurations. So all of this data that is visualized on this dashboard is also available via APIs for the security organization to integrate this data with their custom dashboards and reporting tools. Finally, we're going to talk about user activity. As the user activity dashboard has individual user identifying information, which I cannot display, therefore I have screenshots for the user activity details dashboard. User Activity Dashboard provides insight into user access and their access behavior on the Apigee Edge UI or via the management APIs, and as well as change in user activity over the period of time and what type of data they are accessing and percentage of potentially sensitive operations they have performed. If we identify any suspicious activity by a user, we can drill down further on all the activities and actions performed by a particular user, like the resources they have accessed and what action they have taken on those particular resources. To recap, security reporting feature provides us with relevant data points and metrics to evaluate whether API proxies are adhering to security policies and configuration requirements set forth by the organization's digital security team. Lastly, realizing the value of these productive AI and ML features is the key to have highly available and performant APIs for any API program. Next, let's review some real-world business outcomes wherein these features were immensely valuable for our API DevOps engineering team.
Bot traffic is estimated to be 40% of overall internet traffic, and out of those, 20% is bad bot traffic. Speaking of bad bot traffic, one of the anomalies we had was sudden surge in traffic to our auth API during off-business hours, which is odd. Upon diagnosing the issue, we found out that some bad actors overseas were trying to harvest the access tokens from the auth API using bots, specifically bad bots. As this was a major security incident, we moved fast to remedy the issue. Coupled with Apigee Sense and other WAF tools, we were able to successfully block the bot traffic very quickly. Next, network latencies can cause substantial degradation in service and negatively impact the SLAs. Another anomaly detected was network latency and API response times. API transactions were making coast-to-coast round trip to our East Coast data center, even though the traffic originated in US West region, adding substantial latency and negatively impacting our customers' digital web experience. Upon diagnosing the issue, the major cloud provider unconsciously made changes to their networking routing logic. To alleviate the issue for interim, we made few routing logic changes in our API flow, but ultimately the cloud provider was able to permanently fix the network issue on their side. New product launches and new promotions, like our latest Scam Seal and Carrier Move, are big events and can bring huge surge in traffic to our websites. Next anomaly detected was a sudden burst in API traffic for T-Vision APIs when they were launched. We expected a surge, but not to the extent of 700% increase. Since this was one of the SaaS environments, Apigee support team at Google was contacted to check upon autoscale capabilities of the Apigee runtime components to handle the additional load. All of these incidents were detected by API monitoring, which is a testament to AI and ML capabilities for automated monitoring and alerting, along with the ability to dig deeper into an anomaly or incident in real time to diagnose the issue and find resolution for it. To conclude, AI and ML have significantly transformed the business of operating APIs, and in near future, using advanced predictive analytics, the ability to predict incidents before they impact customer and probably self-resolve will elevate it to the next level. Thank you, and back to you, Manoj.
That's awesome. Thank you everyone for tuning in. Hope you have got a good insight on how you can apply AI and ML to your API programs. Feel free to post any questions or comments that you may have in the Q&A module, and we'll be more than happy to address them. Once again, thank you so much for tuning in and have a very nice day.